Good morning, future statisticians. Have you at a certain point in your life asked yourself how you could possibly decide to put a business in gain your expected profit? Or wonder if a judge in a trial could have given a wrong decision in determining who's guilty? Or possibly think if your classmates' average weights differ significantly among your age? Imagine how a newly discovered medicine is being tested for human treatment. This is Rodrigo Jr. P. Rulloda, your statistics and probability teacher. This lesson will guide you to acquire the following skills or competencies. First, illustrate null hypothesis, alternative hypothesis, level of significance, rejection region, and types of errors in hypothesis testing, and identify the parameter to be tested given a real-life problem. Before we proceed with our lesson, we will check what you already know about the lesson. Make sure you have with you your ball pen and module. Answer the multiple choice questions to get an overview of the concepts that we shall be studying in this module. Write the letter of your answer before the number.
Let us now proceed with the pre-assessment. You are given 5 seconds for each item. Number 1. This refers to an intelligent guess about a population proportion. Letter A. Hypothesis. B. Test statistic. C. Decision. And letter D. Interpretation. Time is up, and the answer is letter A. Number 2. When the null hypothesis is rejected, which of the following is true? Letter A. There is sufficient evidence to back up the decision. Letter B. There is no sufficient evidence to back up the decision. Letter C. The conclusion is guaranteed. And letter D. The conclusion is not guaranteed. Time is up, and the answer is letter A. Number 3. The level of significance of a 95% confidence level is A. Alpha is equal to 0.01. Letter B. Alpha is equal to 0.05. Letter C. Alpha is equal to 0.10. And letter D. Alpha is equal to 0.025. Time is up, and the answer is letter B. Alpha is equal to 0.05. Number 4. The level of significance is also known as A. Probability of type 1 error. Letter B. Probability of type 2 error. Letter C. Validity error. And letter D. Beta error. Time is up, and the answer is letter A. Probability of type 1 error. Number 5. The purpose of hypothesis testing is to reach a conclusion about blank by examining the data contained in blank. Letter A. A population, a sample. Letter B. An experiment, a sample. Letter C. A population, an experiment. And letter D. A sample, a population. Time is up, and the answer is letter A. A population, a sample. For the remaining items, pause this video and continue answering the pre-assessment. Let us now check your answers. Number 1A, 2A, 3B, 4A, 5A, 6D, 7D, 8A, 9D, 10B, 11D, 12C, 13C, 14C, and 15D.
In junior high school, you were taught that there are two branches of statistics. These are descriptive statistics and inferential statistics. Descriptive statistics is a method of collecting, organizing, summarizing, and describing data from sample or population. Inferential statistics is a method consisting of generalizing from samples to populations, performing estimations and hypothesis tests, determining relationships among variables, and making predictions. The decisions we need to do in life are oftentimes hard. As we grow older, our problems become more complicated, so that decisions must be made with careful weighing of things. In weighing our choices in life, our skill of discernment will be put to the test. Discernment is a time-honored practice in Christian tradition. In essence, discernment is a decision-making process that honors the place of God's will in our lives. It is an interior search that seeks to align our own will with the will of God in order to learn what God is calling us to. Every choice we make is an opportunity to align ourselves to the will of God. So, in your next big or small decision in life, what do you think are the important things to consider before taking action? Let us now proceed to the main discussion of our lesson. The statistical hypothesis is a conjecture about a population parameter. This conjecture may or may not be true. There are two types of hypothesis: the null and alternative hypothesis.
Let us now define null hypothesis and alternative hypothesis. Null hypothesis is usually denoted by letter H with subscript 0. It is pronounced as H null or H0, while alternative hypothesis is also denoted by letter H with subscript 1 or A, which is pronounced as H1 or H alternative. So null hypothesis is a statement stating that there is no significant difference between population parameter and the specific value being claimed, while alternative hypothesis is a statement stating that there is a significant difference between population parameter and the specific value being claimed. This is a statement that will be true once the null hypothesis is rejected. Here are common phrases used in hypothesis testing. For null hypothesis, we have the equal sign, which read as, is equal to, is the same as, is exactly the same as, and has not changed from. Under alternative hypothesis, we have the not equal sign, which read as, is not equal to, is not the same as, is different from, and has changed from. Here's another one for null hypothesis. We have here the greater than or equal to sign, which read as, is at least, is not less than, and is greater than or equal to. And for alternative hypothesis, we have here the less than sign, which read as, is decreased, is less than, is lower than, is below, is smaller than, is decreased from, is reduced from, and is not more than. Lastly, for null hypothesis, we have here the less than or equal to sign, which read as, is at most, is not more than, is less than or equal to. And for alternative hypothesis, we have here the greater than sign, which read as, is increased, is greater than, is higher than, is above, is bigger than, is longer than, and is more than. For this time, let us take a look on these following examples on how to write the null and alternative hypothesis in words and in symbols. Example number 1. The mathematics teacher claims that the mean IQ of statistics students is 110. The mean IQ of the 32 randomly selected statistics students is 112, which is more than what the mathematics teacher claims. Can it be concluded that the mean IQ of statistics students is not 110? In the given scenario, we are concerned with the population mean since our topic focuses on mean IQ of statistics students. Therefore, our parameter is the mean IQ of statistics students. Now, the claim of the mathematics teachers is that the population mean is 110. Then, our null hypothesis is the mean IQ of statistics students is 110, or mean is equal to 110. However, from a sample of 32 students, the computed sample mean is 112, which is not equal to the claim of the mathematics teacher. Thus, our alternative hypothesis is the mean IQ of statistics students is not 110, or mean is not equal to 110. Example number 2. The LB company produces an average of 4% defective bulbs each day. Recently, some of the machines were upgraded. Out of the 400 bulbs randomly selected, only 14 bulbs were found defective. Does this suggest that there is a decrease in the number of defective bulbs produced each day? For this situation, it shows the proportion of defective bulbs. Therefore, the parameter is the proportion of defective bulbs produced per day. Before the machines were upgraded, the average defective bulbs produced per day by the LB company is 4%. Therefore, the null hypothesis is the proportion of defective bulbs produced per day is 4%, or P is equal to 4%, or P is equal to 0.04. After the machines were upgraded, the company claims that there is a decrease on the number of defective bulbs produced per day. Therefore, the alternative hypothesis is the proportion of defective bulbs produced per day is less than 4%, or P is less than 0.04, or P is less than 4%.
It is noteworthy to remember that the null and alternative hypothesis cannot be true at the same time. A statistical test will be conducted to the data from the sample in order to make a decision on whether the null hypothesis should be rejected or not. In doing hypothesis testing, there are 4 possibilities that could take place.
This table shows the 2 types of error that could occur when the decision made does not align with the true state of nature. The 2 types of error are: first, the type 1 error, wherein if the null hypothesis is true and you rejected that null hypothesis, then you committed a type 1 error. So type 1 error is committed when the researcher rejects a null hypothesis when in fact it is true. The probability of committing type 1 error is called the level of significance. Alpha is used to represent the probability of a type 1 error. But if the null hypothesis is true and you did not reject that null hypothesis, then your decision is correct. Similarly, if the null hypothesis is false and you rejected that null hypothesis, then your decision is correct. But if the null hypothesis is false and you did not reject that null hypothesis, then you committed a type 2 error. Type 2 error is committed when the researcher fails to reject a null hypothesis that is false. Beta is used to represent the probability of a type 2 error.
In our inference, we base our decision from only one sample. Thus, there is a possibility that we may commit an error. However, to minimize the probability of committing a type 1 error, we can decrease the value of the alpha, also called the significance level.
The level of significance alpha corresponds to the rejection region, and the difference of 1 and the alpha corresponds to the area of the curve occupied by the non-rejection region. The most commonly used values for alpha are 0.01, which is 1%, 0.05 or 5%, and 0.1 or 10%. When the study deals with the life and death situations, it is advisable to use 0.01 or less. But when it is on social research, it can simply use 5% or 10%. For each level of significance, there corresponds a level of confidence. For example, a level of significance of 5% corresponds to a 95% level of confidence. This figure shows the rejection and non-rejection region. The rejection region, or also called the critical region, this part of the normal curve, is the range of values of the test value that indicates that there is a significant difference between the actual value of the parameter and its hypothesized value. This means that the null hypothesis should be rejected. And this non-rejection region, or what we call the non-critical region or acceptance region, is the range of values of the test value that indicates that the difference was probably due to chance and that the null hypothesis should be rejected. To identify the rejection and non-rejection area, which will be our basis in accepting or rejecting the null hypothesis, we need to identify the nature of our hypothesis first. To identify the nature of our hypothesis, we have to consider the types of tests. We have two types of tests, the one-tailed test and two-tailed test. And under one-tailed test, we have the right-tailed test and the left-tailed test. One-tailed test is also called the directional test, wherein the rejection region is on one side of the mean. If the alternative hypothesis has the inequality symbol greater than, then it is right-tailed test because the rejection region is on the right tail of the normal curve. And when the alternative hypothesis has the inequality symbol less than, then it is left-tailed test because the rejection region is on the left tail of the normal curve. The second type of test is the two-tailed test. This is what we call the non-directional test. The rejection region is on both sides of the curve. So if you observe from the figure, if this is the normal curve, we have two rejection regions, from the left and from the right. If the alternative hypothesis contains the inequality symbol or the not equal symbol, then the test is two-tailed, wherein alpha, which corresponds to the rejection region, is divided equally between the two tails. That's why we have alpha over 2, and on the other side we also have alpha over 2.
The point that separates the rejection and non-rejection area is called the critical value, which is derived from the level of significance. In hypothesis testing, the following are the most common critical values based on the level of significance and type of test.
This table shows the critical values. We need to know our level of significance, level of confidence, and the type of test, if it is a left-tailed test, a right-tailed test, or a two-tailed test. If the level of significance is 10%, the level of confidence is 90%. The critical value of a left-tailed test is negative 1.28. For right-tailed test, positive 1.28, and for two-tailed test, positive and negative 1.645. If the level of significance is 5%, then the level of confidence is 95%. The critical value of a left-tailed test is negative 1.645, and the critical value of a right-tailed test is positive 1.645. And for two-tailed tests, it is positive and negative 1.96. If the level of significance is 1% and the level of confidence is 99%, therefore, the critical value of a left-tailed test is negative 2.33, for right-tailed test positive 2.33, and for two-tailed test it is positive and negative 2.575. Here are real-life examples on how to find the critical values. A popcorn company says that at least 95% of their kernels will pop when microwaved. A critic says this is too high of a claim for a 90% level of confidence. The critic says that the claim is too high. Thus, he is pertaining that the proportion should be less than 95%. So the parameter is the proportion of kernels that will pop when microwaved. And the alternative hypothesis is the proportion of kernels that will pop when microwaved is 95%, or P is equal to 0.95. And the alternative hypothesis is the proportion of kernels that will pop when microwaved is less than 95%, or P is less than 0.95. Since the level of confidence is 90%, then the level of significance is 10%. And since alternative hypothesis uses a less than symbol, this makes it a one-tailed test, specifically a left-tailed test. Therefore, the critical value is negative 1.28. So if we're going to draw a normal curve, then the rejection region is on the left tail, while the non-rejection region is on the right side of the normal curve. For the second example, the Green Boat Company claims they are able to sell 200 boats per year. In the year 2018, it was recorded that they sold 250 boats. With 99% confidence level, is it enough to prove that the average sold Green Boat Company is not 200? The parameter is the average number of boats sold per year by Green Boat Company. The null hypothesis is the average number of boats sold per year by Green Boat Company is 200, or mean is equal to 200. And the alternative hypothesis is the number of boats sold per year by Green Boat Company is not 200, or mean is not equal to 200. Since the level of confidence is 99%, then the level of significance is 1%. Since the alternative hypothesis used a not equal sign, then this means that it is a two-tailed test. Therefore, the critical value is positive and negative 2.575. And if we're going to draw a normal curve, we have two rejection region.
To solidify your understanding and skills of the topic, accomplish the following activities. First activity, write the null and alternative hypothesis in words and in symbols for each of the situation.
Number 1. A pharmaceutical company claims that their pain reliever capsule is 70% effective, but a clinical test on this capsule showed 65 out of 100 effectiveness. Number 2. A politician believes that he is favored by 85% of voters. An opponent says this is too high for him to claim. Number 3. An electric company says that the average consumption of residents in a certain town is 300 kilowatt-hour per month. However, the town's mayor says their town's residents consume less. Number 4. A barangay official claims that the mean family income of his constituents is 30,000 pesos, but some group of residents believe that this is not true. Number 5. A fitness club claims that their routines can elevate heart rates of up to 200 beats per minute on the average. A critic says this is an overestimate of the actual average. Let us now check your answers. For number 1, we have the null hypothesis is the pain reliever capsule is 70% effective, or P is equal to 70%. The alternative hypothesis is the pain reliever capsule is not 70% effective, where P is not equal to 70%. For number 2, the null hypothesis is the proportion of voters who favor the politician is 85%, or P is equal to 85%. For the alternative hypothesis, the proportion of voters who favor the politician is less than 85%, or P is less than 85%. For number 3, the null hypothesis is the average electric consumption of residents per month is 300 kilowatt-hour, or mean is equal to 300. And for alternative hypothesis, the average electric consumption of residents per month is less than 300 kilowatt-hour, or mean is less than 300. For number 4, the null hypothesis is the mean family income of the residents is 30,000 pesos, or in symbol, the mean is equal to 30,000 pesos. For the alternative hypothesis, the mean family income of the residents is not 30,000 pesos, or in symbol, mean is not equal to 30,000 pesos. Lastly, for number 5, the null hypothesis is the average elevation of heart rate is 200 beats per minute. In symbol, mean is equal to 200 beats per minute. For alternative hypothesis, the average elevation of heart rate is less than 200 beats per minute, or in symbol, mean is less than 200 beats per minute.
For the next activity, given another set of situations, determine whether the test is one-tailed or two-tailed test.
Number 1. A researcher claims that a method of teaching affects learning. Number 2. A food additive enhances food flavor. Number 3. The study habit improves the memory. Number 4. Health is related to lifestyle. And number 5. People's culture affects tourism. Let us now check your answers. Number 1. Two-tailed test. Number 2. One-tailed test. Number 3. One-tailed test. Number 4. Two-tailed test. And number 5. Two-tailed test.
Good job! You have successfully finished the tasks given. Now, let us summarize what you have learned today by completing the thought of the sentences with the appropriate words.
Here are the first 4 items. Number 1. The statement "there is a difference between a parameter and a specific value" is called blank. Number 2. When the value of the test statistics lie on the rejection region, we will blank the null hypothesis. Number 3. In hypothesis testing, the maximum allowable probability of committing a type 1 error is symbolized by blank. Number 4. A 99% confidence level corresponds to blank level of significance. Continue answering the remaining items. Let us now check your answers. Number 1. Alternative hypothesis. Number 2. Reject. Number 3. Alpha. Number 4. 1% or 0.01. For number 5, critical value. Number 6, left-tail test. Number 7, two-tail test. And number 8, hypothesis testing.
You are now ready to transfer your new knowledge or skill into real-life situations. Given the null and alternative hypothesis, you are tasked to determine the hypothesis test used. Maybe a left-tailed, right-tailed, or two-tailed. Then sketch the graph of each to represent the rejection and non-rejection region.
Number 1. Null hypothesis is mean is equal to 25. Alternative hypothesis is mean is not equal to 25. Number 2. Null hypothesis is mean is equal to 350. Alternative hypothesis is mean is greater than 350. Number 3. Null hypothesis is mean is equal to 75. Alternative hypothesis is mean is not equal to 75. Number 4. Null hypothesis is proportion is equal to 0.9. And for alternative hypothesis, proportion is less than 0.9. Number 5. Null hypothesis is proportion is equal to 0.35. Alternative hypothesis is proportion is greater than 0.35. We will now check your answers. Number 1. Two-tail test. Number 2. Right-tail test. Number 3. Two-tail test. Number 4. Left-tail test. And number 5. Right-tail test.
Great job! You can now apply what you have learned. Finally, to evaluate your level of mastery in achieving the learning competencies, answer the given post-assessment in your module. Write the letter of your answer before the number.
Here are the first two items. Number 1. The purpose of hypothesis testing is to reach a conclusion about blank by examining the data contained in blank. Letter A, a population, a sample. Letter B, an experiment, a sample. Letter C, a population, an experiment. Letter D, a sample, a population. Number 2. Which of the following statements is true? Letter A, exactly one of the null or alternative hypotheses must be true. Letter B, both the null and alternative hypothesis must be true. Letter C, it is possible for both the null and alternative hypothesis to be true. Letter D, it is possible for neither the null hypothesis nor alternative hypothesis to be true. For the remaining items, pause this video and continue answering the post-assessment. Let us now check your answers. Number 1A, 2A, 3D, 4D, 5B, 6D, 7A, 8A, 9B, 10A, 11D, 12C, 13A, 14A, and 15B.
Give yourself a thumbs up. You are almost done with the module. Hang on! Here is one last activity. To enrich your knowledge or skill of the lesson learned, accomplish the additional activity in your module. You are tasked to identify the null hypothesis, alternative hypothesis, level of significance, and level of confidence of the following. Afterwards, sketch the graph of each item to show the rejection, non-rejection region, and critical value, maybe a left tail, right-tailed, or two-tailed?
Don't worry, we only have 2 items for this activity. Number 1. A librarian of a school claims that all their grade 8 students read an average of 10 storybooks a month with a standard deviation of 2 books. A random sample of grade 8 students read an average of 12 books a month and a standard deviation of 1 book. The confidence level is 95%. Number 2. A government agency is investigating a complaint from one concerned citizen who said that there is a short wait selling of rice in a certain town. An agent manufacturer took a random sample of 20 sacks of 50 kilo sacks of rice from a large shipment and finds that the mean weight is 49.7 kg with a standard deviation of 0.35 kg. The level of significance is 0.01. Let us now check your answers. Number 1. The average number of read books per month of grade 8 students is the parameter. The null hypothesis is mean is equal to 10. Alternative hypothesis is mean is not equal to 10. The level of confidence is 95% and the level of significance is 5%. Since the alternative hypothesis used a not equal sign, therefore the critical value is positive and negative 1.96 because the situation is a two-tailed test. Number 2. The mean weight of rice sold in a certain town is our parameter. The null hypothesis is mean is equal to 50 and the alternative hypothesis is mean is less than 50. The level of confidence is 99%, therefore the level of significance is 1%. Since the alternative hypothesis used an inequality symbol which is less than, it shows that it is a left-tailed test. Therefore, the critical value is negative 2.33.
Congratulations for completing all the activities in your module. I hope you will apply what you have learned in your future careers. See you in our next lesson. Bye!